So we're going to have a look at another advanced mechanics question. Here we're told a dart is fired at an angle of 60 degrees upwards, and it has a maximum height, reaches a maximum height of 25 meters. We have to find its initial velocity. So this is a sort of reversal of a lot of the questions that you normally see here. Normally you're told the initial velocity, you're told the angle, you're asked for the max height or things like that. This time we're going backwards. So we'll draw a little diagram over here. So we have some dart, some object is fired, it goes up like this, it'll have some parabolic path that looks something like this. This angle was 60 degrees. This initial velocity here is unknown. So velocity initial is unknown. The velocity initial in x is unknown. And the velocity initial in y is also unknown. So we don't know any of this. We do know that its maximum height was 25. So that's one piece of information that we have. They also don't tell us the time at which that maximum height occurs. So there's very, very little information in this question. So we want to think about our acceleration, velocity, and position equations. Acceleration in x, we know is always 0. Acceleration in y, we know is minus 9.8, which is just the acceleration from gravity. The velocity in x is just the initial velocity in x. Now we don't know what this is, but we can find it as a function of the initial velocity by using the cosine rule. Cosine of 60, by using SOHCAHTOA, the cosine rule from SOHCAHTOA. Cosine 60 is the initial velocity in x over the initial velocity. This means velocity initial in x is initial velocity times cosine 60. So this means velocity in x is going to be whatever the initial velocity is times cosine of 60. The velocity in y we can also find using this same method. We can say sine of 60 is VIY over VI, and that means VIY is VI times sine of 60. So here we have VI times sine of 60. Now cosine of 60 and sine of 60 we could find exact values or decimal approximations for. We're just going to leave them for the time being. So this is what we have. We have our accelerations, we have our velocities. And the velocity in y is in fact this minus 9.8 times time. We don't know the time at which this maximum velocity occurs, so this is going to cause us a little bit of a problem. We can find the position equations though. Position in x we know will be VI cosine of 60 multiplied by time, and the position in y we know will be minus 4.9 times time squared plus VI sine 60 times time, and both of these could have a plus x0 plus y0. x0 and y0 are both 0 because we have decided where this starts at the origin. So these will just be 0 and they'll go away in these particular cases. So we have a whole bunch of equations here, and we can try and solve these equations in order to get unknown values. We can then use those unknown values in order to find the unknown value we're after, which is the initial velocity. So let's have a look at these. First, we know that y is equal to 25 at the max height. So y equals 25 when v of y is equal to 0. So velocity of y equals 0 implies that the position of y is 25. These happen at the same time. We don't know what this time is, but we know that these things happen at this same time. So we're going to use the velocity in y formula here. We're going to say that the velocity in y is equal to 0, and this is equal to the initial velocity times sine of 60 minus 9.8 times time. Now we can rearrange this for time, add 9.8t to both sides. 9.8t. This gives us 9.8 times time is equal to the initial velocity times sine of 60. Divide both sides by 9.8. And this tells us that the time at which the object is at its maximum is whatever the initial velocity is times sine of 60 divided by 9.8. Now we can decimal approximate sine 60 on 9.8, and I'm actually going to do this at this point. It's just going to make it a little easier. Sine 60 over 9.8 gives me 0.088. So this is 0.088 times whatever the initial velocity is. We know P of y is 25 at this time. So we can plug t equals 0.088 vi into our position in y formula. So we're going to get position in y is equal to 25, and this is minus 4.9 times time squared, which is 0.088 vi squared, plus vi sine 60 times t, vi times sine of 60 times time, which is 0.088 vi. Now here we have something which only contains as its unknown vi, and this is what we want, right? The whole point of this question was to find the initial velocity. We have now used the formulas for acceleration, velocity, and position, restructured them and reworked them in such a way that we have a formula which is only a function, we have a formula in which the only unknown is vi. We can solve this for vi. Once we have that vi, the question is done. So we have to be careful to do this and to not mess it up, but it should be smooth sailing from this point onwards. So we have 25 is equal to minus 4.9 times 0.088 squared. This gives me minus 0.0379 times vi squared, plus vi times vi gives us a vi squared in the next term, sine 60 times 0.088. This gives me 0.0762 vi squared. So now we have 25 is equal to the sum of these two terms. These are now like terms. So we have minus 0.0379 plus 0.0762. That is 0.0383. 0.0383 times vi squared. Divide both sides by 0.0383. 0.0383. Cancels this, cancels this. Take the square root of both sides. I get the initial velocity is the square root of 25 over 0.0383. So square root of 25 over 0.0383. I've got 25.55. 0.55, that is to 2 decimal places, and that is in meters per second. And this is the answer that I was after here. So there was a whole lot of work in here. Right? We went through a whole bunch of steps in order to construct a formula to let us find this initial velocity. We also did a whole lot of rounding. So as I went through this question, I rounded very often. If this was a maths class, this would be considered in bad taste. Right? It would be considered inappropriate to constantly round. The maths teacher would say, you know, what the hell are you doing? Why are you rounding so much? Your answer is now wrong. You know, this is not okay. This is not a maths class, as it turns out. This is a physics class. Physics is about using what you know about physical laws in order to find what happens in certain physical circumstances. So the fact that we are constantly rounding through this question is fine, right? The minute you start doing physics, most branches of physics, you lose the concept of absolute perfection, right? You have to throw perfection out the window in order to do physics at all, because now what you're doing is you're mapping mathematics to a physical world, and that does not go across perfectly. So the fact that we're rounding all the time, some people will say, oh, there's a lot of rounding here. That means the answer might end up, plus minus 5% from the real answer. Fine. That's perfectly fine. This is just an approximation anyway. Right, so when we're doing these kinds of questions, that's what you're after. You're after approximations. When you get into physics more, physics or engineering or any of the applications of it, then you will start thinking about how far from a possible real answer could you be. In this question, we've not been told to specify that. We've just been asked for an approximation. So in fact, I wrote this question. If I was marking this question, the working that I've presented in these slides would be one perfectly acceptable way in order to find the answer. And if your teacher specifies otherwise, follow the specifications they give you because they are giving you marks. If they don't specify otherwise, any method will be fine, right? Because physics is about using intuition and mathematics in order to map concepts to the real world, solve mathematical equations which are mapped as concepts, find values from that. Right? So you're always going to have uncertainty, you're always going to have variations from the correct answer. So 25.55 is roughly correct.